Welcome everybody to the DBT sponsored SATH project, which is a seamless, affordable, assistive technologies for health. And this is a project which is actually supervised by 4 institutes, IIT Kanpur and IIT Bangalore, KTH Sweden and University of Gävle of Sweden. We have developed here the active stick systems, helps in terms of the mobility of the people. Just very briefly, this is a system which takes care of couple of things: uneven surface movement of the people, along with very ergonomic handling of the system, and most importantly, which is what is one of the very novel feature of the system, it actually takes care of the sit to stand and stand to sit motion support for an elderly people. And this is done by actually taking care of the actual muscular movement, taking feedback from that. The system intelligently controls the speed so that an effective support can be given to the elderly people. And right now I will request Mr. Shubham and Mr. Harshit to explain the nitty-gritties of this particular active stick.
Hello everyone. So we will present every feature and specifications of this active smart stick that we have developed. So coming to the basic specifications of this stick. So a stick will take maximum height of around 96 centimeter, and the weight of this stick is around 1.45 kilogram. And this maximum uplift force or the push that the stick will be able to provide will be around 134 Newton, and this stick is designed in a for a 1200 Newton force with a design factor of safety of 3.5. First feature of this smart stick, this provides a customizable height adjustment. As you can see, there is a pin lock over here and there are 2 telescopic rods, and this this pin, if we push this pin and then we will insert it in these holes, then it will provide a feature of height adjustment over here. The second feature of a stick is the stick changes its height during STS motion. The STS is sit to stand motion. The stick will have different height during sitting and different height during standing position, and you will see later in this presentation like it will change its height. Next feature of this stick is this ergonomically designed handle. So handle is the part of a stick which will be in directly contact with the body part, like with the hand. So we kept a lot of things in mind, like this curvature of handle with the optimum wrist angle, and this grips with the human finger measurements, and this design of handle, the derby mixed with the derby handle and the normal handle. So according to that, the handle is designed in very ergonomical way. So next feature of this stick is uplift force during STS motion, or I would say this is the key feature of this stick. So during the STS, the elderly people faces a lot of problem, like STS is a very energy demanding task, and sometimes they are even unable to get by themselves alone. So we have designed the stick in this manner, like it will provide an uplift or it will dynamically elongate during the STS motion. So as you can see in the demonstration also, like how the stick is changing its height according to the person's movement. If the person is standing, stick is also increasing its height, and if person is sitting, stick is decreasing its height. And also, like we have included the feature, the stick will stop at the moment when the person is going to stop. So next feature of this stick is reduction of jerks or reduction of impact from the ground while walking. So for that we have designed this honeycomb structure over here, as you can see. So it has basically 2 major properties. First is that it is very elastic in nature. So for the elastic, it will provide an ergonomically step movement while walking. And secondly, as you can see in this demonstration, it's very damped, and it's designed in a such a way that it will absorb the shock while we will push the stick, or it will reduce the jerks coming from the ground. So another kind of impact generally elderly people faces is impact on hand. So for that we have designed this system, like I will press this, and when I press it very hardly, then only it will be able to press this, and this will be very damped in nature so that it can provide an ergonomically shock absorption. So the stick is designed in a such a way, like it will not destabilize the person's movement while moving on rough planes or inclined planes. As you can see also in the demonstration, we put this stick on inclined planes, and the honeycomb structure is deformed in such a manner that it will keep the stick stable. So falling is a very crucial issue among the elderly people that need to be addressed. So you can see in the demonstration, it is deforming in such a way that it will first tilt rather than toppling. So it will give some time or some relaxation for the person to get balanced. So suppose accidentally if there is a fall, then a stick is smart enough that it will detect the fall. So as you can see in the demonstration also, if the stick is falling, the person is falling with the stick, then it is sounding an alarm. Or later we will connect it to the Bluetooth of phone so that it can make a call of relatives in case of emergency.
Hello friends, my name is Harshit and I will be demonstrating the electronics of the active smart stick system. The electronics is divided into two sub-modules. One is the angular feedback unit and one is the stick control unit. So the angular feedback unit, as the name suggests, it provides with the angle at which the user is standing or sitting. It has a gyroscope and the gyroscope provides the angular velocity from which we can figure out the angle at which the person is sitting or standing. The angle is transmitted via Bluetooth to the stick control unit. The stick control unit is the circuitry which is mounted on the bottom of the stick. It receives the angle from the angular feedback unit and then correspondingly actuates the stick. Now the actuator drives in a controlled manner. This control is governed on the movement of the hand of the human. The movement of the hand is not as a linear, it's not in a linear way, and then the actuator is moving in such a way that as the hand progresses upwards, the actuator will vary its speed, and in turn it will also vary the length at which the actuator is moving. Thank you for viewing our demonstration of the active smart stick. We have designed this stick with the motive of helping the elderly people in their daily movement.
A lot of research and effort has gone while making this stick, and we hope that you liked it. And we will also love to hear your valuable suggestions so that we can also improve in making further prototypes.
Thank you.
Thank you.